Lesson 7-4, Polynomials. A polynomial is a monomial or the sum or difference of monomials. You also have some monomials that have special names. One is a binomial, and this is the sum or difference of two monomials. Or the trinomial is the sum or the difference of three monomials. So if you see the prefix of those words, it's tri, which is 3, and bi, which is 2. When identifying polynomials, you are looking for adding or subtracting of monomials with non-negative exponents. So let's look at some examples. We have negative 6.5. We would say that yes, this is a polynomial because negative 6.5 is a real number. You would categorize it as a monomial because you're not combining 2 to make it bi, and you're not combining 3, it's just 1. So it's one monomial, it's single. 10x to the negative fourth minus 8x squared. This one you would say is not a polynomial because of the negative in the exponent, because that would actually turn this into a fraction, which is division, and we know by definition polynomials are just adding and subtracting. And then you also have 4y minus 5xz, and you would say yes, that this is a polynomial, and you would actually categorize this one as a binomial because you're combining two monomials together. When we are looking at the degree of a monomial, this is the sum of the exponents of all its variables. So if you just have one monomial, you're just adding up the exponents, and the degree is what is the sum of those exponents. And then that degree has a specific name, which we'll talk about in just a moment. Non-zero constant has a degree of 0. 0 has no degree, and we'll look at some examples. A degree of a polynomial is a little bit different. It's the greatest degree of any term in the polynomial. So you first want to find the degree of each one of the terms, and then you want to find the degree of each term and determine which one is the greatest. So let's take a look at this example. So this problem says find the degree of the polynomial. So you're looking at this and you have two things that are being combined here. You have two different monomials making this a polynomial, and you're combining them. So we want to find the degree of it, which means we have to find the degree of each separate one. So for this one, you add your exponents of 2 plus 3, and then that 3 kind of up front has a 0. So you have 2 plus 3. So the degree for this set of terms, or the monomial, is the 5. So then we go over to the 6 and we find the degree of this, and because it is just a single number, it's a constant, it's a number that never changes, it has a degree of 0. And so if you look and you have a degree of 5 and a degree of 0, you pick the greatest degree, so the degree of this polynomial would be 5. Pause the video to try a few examples. For the first example, in finding the degree, we have 7x to the 5th y. So it is a monomial, and so you just have to add your exponents. Well, you have the 5, and then you have the y, which does not have an exponent visible, but we know it's a 1. So you add those two together, and you would get 6. For the next example, it is a trinomial, so you would have multiple different things, so we have to find the degree of each specific term. So let's start with the easiest one, the 13. It's a constant, so it is a degree of 0. So then we'll go back to the left. We have our first term, which has 2 exponents, and each one is 1. So we add those together and get 2. We add the exponents for 3rt squared, and we get 3 because the exponent for r is 1. And then we add the exponents for 7r squared t to the third, and we get 5. So again, we know that we go with the greatest degree when we're in anything other than a monomial. So the degree of this would be the 5 because you go with the greatest. So we can also write polynomials in standard form. This looks a little bit different than standard form when we were talking about graphs. When they are written in standard form, the terms are in order from greatest degree to least degree. That's where the degree part kind of becomes important. The coefficient of the first term is called the leading coefficient. So if we had an example of a standard form polynomial, it would look something like this. We would have 4x to the third minus 5x squared plus 2x plus 7. You can see that the greatest degree is this one because it's x to the third, and then x squared, and then x, and then no degree. And so the leading coefficient would be the 4. This would be your leading coefficient. So let's look at this example together. We are working on writing this example in standard form. So we have 3x squared plus 4x to the fifth minus 7x. And so you want to look at the degrees of each term. This degree is 2, this degree is 5, and this degree would be 1. So we're going to put the 4x to the fifth at the beginning, the plus 3x squared, and then the minus 7x. When you're ordering these and you're moving numbers around, make sure that the sign in front of the number travels with the number. It's not an addition or subtraction sign when you're moving numbers. It actually becomes a positive or a negative, and it is attached to the number. Pause the video to complete the lesson review. Make sure you show me this lesson review for verification of watching this video.